Okay, so the purpose of this is to solve this using Laplace transform. By the way, if you try to use the matrix way, where you put the matrix 1, negative 2 is 18, and negative 11, and find the eigenvalues and eigenvectors, you'll see that the eigenvalue equation has a double root. And that's a lot harder than when you have a distinct root. So it's like certainly doable, but it's very hard. Okay, so probably using the Laplace transform for this one would be a better approach as well. Even if I didn't say use Laplace transform, maybe using Laplace transform might be better. Okay. All right. So we are going to take Laplace transform both sides. Remember, the derivative transform as s times the Laplace transform. So as I explained, the beauty of the Laplace transform is that it changes all the derivatives as multiplication by s's, right? And then there's an initial condition involved. So this much is the Laplace transform of x prime. The right side is capital XS minus 2y s. And then likewise sys minus y of 0 equals to 18 xs minus 11 ys. Right. Now we plug in the initial values 1 and negative 2. So you should really write this again, but I'm being lazy, so I'll just put 1 here, and then negative of negative 2 is plus 2. Right? So we now have a system of algebraic equation, and the primary goal is to find x of s. And then after this, find y of s. Okay. Once you find x of s and y of s, then you have to find x t, y t by inverting the Laplace transform. Okay, so how do you solve this system? Well, here the unknowns are xs and ys, the two functions of s. And at first you might not know what to do, because you probably never have solved a system of equations with two of these being functions. But just remember that for any system, you solve one equation for one of the unknowns and you plug into the next one. That's how you solve. So we're just going to do that. So what I'm going to do is I'm going to take the first equation, move this to the left, move the negative one to the right. And the result is you have s times xs minus xs equals to negative 1, no, actually positive 1 minus 2 ys. And then because this factors as s minus 1, all you have to do is now divide by s minus 1 both sides. And there it is. That's your x of s. Not quite, because you still don't know what y of s is, so you have no other choice but to plug this into the next one. So let's see what that gives us. That gives us s of ys plus 2 equals to 18 times 1 minus 2 y of s over s minus 1, and then minus 11 of ys. So if you look at what I did was, all I did was I took this second equation and replaced xs by this on the right side. Yeah, and now you see that this equation only has y of s as the only unknown. That's the only unknown, so we can easily solve for y of s in principle. But before I do that, I don't like fractions at all, so I'm going to multiply by the denominator both sides to get rid of the denominator. That's always a good idea. So I'm going to multiply s minus 1 here, s minus 1 here, s minus 1 here. And the result is s times s ys is s squared ys. Negative 1 times sy will be negative sys. S times 2 will be 2s. Negative 1 times 2 will be negative 2. Equal to these two will cancel away, so now you just have to multiply 18 to each one of them. So that's going to be 18 minus 36 ys. And then negative 11 sys with plus 11 ys. Okay. In order to solve for y of s, you're going to identify all the terms that have ys's in there. Move every one of these to one side. Whereas the ones without the y of s, these should go to the other side. Let's do that. And once you move everything to the left side, every one of them will have y of s in there, so I'm going to factor the y of s out. Let's write down what we get. You get s squared minus s. Then negative 36 moved to this side will be plus 36. Minus 11s moved will be positive 11s. Positive 11 subtracted will be minus 11. Equals to negative 2 moved to the other side will be 18 plus 2, which will be 20, minus 2s. Okay, and then if I simplify this, this is s squared plus 10s plus 25, capital Y of s, equals to, let's write negative 2s plus 20. Let's switch places. And I see that this can be factored. How does this factor? S plus 5 times s plus 5, right? It's s plus 5 squared, actually. It's a complete square. So you divide, you get y of s equals to negative 2s plus 20 divided by s plus 5 squared. Okay. So we found y of s. It's pretty nice, right? But we still have to figure out x of s because we didn't fully find x of s. In order to find x of s, you should replace y of s by that thing that we found. So we put x of s equal to 1 minus 2 times this thing, negative 2s plus 20 over s plus 5 squared, divided by s minus 1. So I just have this, but y of s is replaced by this much. And that's a complex fraction, fraction inside a fraction. In that case, you want to multiply top and bottom by the denominator so that this will later cancel that one. All right, so what does that give us? That gives us s plus 5, actually this will also be multiplied to this one as well, right? So you have s squared plus 10s plus 25, which is s plus 5 squared. So all I'm writing down is s plus 5 squared times 1, which is this much, right? But then there's a negative 2 times negative 2, which is plus 4s. And then negative 2 times positive 20, which is negative 40, over s minus 1 times s plus 5 squared. And we get s squared plus 14s minus 15 over s minus 1 times s plus 5 squared. And, you know, this is fine. You can already write this as a partial fraction expansion. I mean, you have this and this, so you can easily write this as a partial fraction expansion, right? A over s minus 1 plus b over s plus 5 plus c over s plus 5 squared. However, if you look at the top, some of you might recognize that this can be factored because 15 times 1 is 15 and 15 minus 1 is 14. So you can factor the top, and if you do that, you're going to find a surprise that the top one has s minus 1 as a factor. And if you are wondering how can that be, is it like a coincidence? Well, it's actually not a coincidence because if you know the format of this solution, it's a sum of just two functions, not three functions, but two exponential functions or some form, right? But if you did the partial fraction expansion of this, because this is cubic, it will be the sum of three functions. So one of them will be 0. So if you notice that, then you would expect that in all cases the top will factor and they're going to be simplified. So you just have this nice simple s plus 15 over s plus 5 squared. Okay, so that gives us the x of s and y of s, and now we have to figure out how to invert it. So let's just copy it and we'll erase everything. And by the way, as I do that, try to see if you can actually find the partial fraction expansion. This should be what? A over s plus 5, and then b over s plus 5 squared, right? Try to find a and b. Get to work. Let me copy that, and then I'll start working. So s plus 15 over s plus 5 squared y of s equals to negative 2s plus 20 over s plus 5 squared.
S plus 5.
Okay.
So
Reciprocate everything. Okay, so we start with s plus 15 over s plus 5 squared. You learned in Calculus 2 that to do partial fraction expansion when you have some powers, you start from the lowest power, power of 1, and then you keep increasing it. So if this was a 3, then you would have one more term, c over s plus 5 cubed. If that was 4, you would have 4 terms, and so on and so on. And you don't want to put bs plus c because, I mean, if you combine this into a single one, indeed the top one is a linear over quadratic. So a and b is enough. And we have to find out what a and b are. And how do you do it? You multiply the denominator to the other side. You get s plus 15 equals to a times s plus 5 plus b. And you can either just multiply s plus 5 squared both sides, which is the quicker way, but if you didn't get how this is same, then you can try to combine these two fractions into one. And then if you just look at the numerators, you'll see that this is what you get. Okay? Either way, you get that equation. Now, from here, what should we do? These two sides are equal as functions, so they should be equal for any value of s. So we plug in s equal to negative 5. And negative 5 plus 15, that gives you 10, equals to 0, a times 0, plus b, so that b must equal to 10. Okay. How would you get a?
S equals 0.
That's one way. So you can plug in s equal to 0 both sides, and then you get 15 on the left side, b is 10, and you have 5a. You can solve for a that way. Another possibility is to compare the highest order, in which case is the, that would be the easier way. So what's the highest order here?
S.
S itself. So if you look at the s term, you get s equal to as, right? Because the right side has as as the only term with s, the left side has just s, and therefore a must equal to 1. Check that if you plug in s equal to 0, you get the same answer. So once you get a equals to 1 and b equals to 10, that means x of s is now equal to 1 over s plus 5 plus 10 over s plus 5 squared. And all you have to do now is to invert the Laplace transform to figure out what x of t is. Okay, so look at the Laplace table, see what gives you 1 over s plus 5. It's this formula, Laplace transform of e to the at is 1 over s minus a, right? So apply that formula here with a being negative 5, so you get e to the negative 5t. Okay, what about this one? This one, you're going to use this first one. But for this to be squared, what should be the value of n? 1. So you get 1 factorial over s minus a squared. 1 plus 1 is 2. To be this thing, right? Therefore, what's the inversion of this one?
10.
10.
1 factorial.
Yeah, 1 factorial is 1, so we don't care.
Over s minus much negative 5.
Yeah. Right. All I'm saying is that if you have n equals to 1 and a has negative 5 and you apply this formula, you get exactly 1 over s plus 5 squared.
At this point, we initial conditions here now, or?
No, there's the, well, we're doing Laplace transforms. Laplace transforms use the initial conditions
Okay.
right off the bat. So
So is that just our answer then?
that's xt, but we still have to figure out yt. So we have to do the same thing for yt. So let's write down negative 2s plus 20 over s plus 5 squared. And let me call this as c and d. Or I could still call them as s plus a over s plus 5. I don't think many of you will get confused. But just in case, I'll just call it c and d so that you don't get confused between the previous a and b. Multiply this to the other side, this squared, and then canceling s plus 5 gives you c times s plus 5. This time this will cancel the denominator, you just get d. And you have negative 2s plus 20. Let's check what happens when s equals to negative 5. Negative 5 times negative 2 is?
10.
10 plus 20 is?
30.
30 equals to d. Okay, and then if you compare the s term, what's equal to what? S is the first power term. Negative 2s is cs. So c must be negative 2. Okay? And that means capital Y of s, capital Y of s is negative 2 over s plus 5 plus 30 over s plus 5 squared. And if you're curious that indeed this is same as this, just combine into a single fraction. You will see that indeed you get the same thing. Okay? That's how you check your calculation during the exam. If you weren't so sure about the values that you got and you want to check whether you got it right, just combine it to a single fraction, see if you get this one. Right, anyways, that means what's y of t? Negative 2 e to the negative 5t plus 30 t e to the negative 5t. So those are the answers.